Hi guys, so today we are going to be doing linear programming. Now, what is linear programming? Linear programming is basically a technique that helps you deal with multiple limiting factors. Previously, we have seen throughput accounting, which did not deal with multiple limiting factors, which only dealt with one limiting factor. Okay, but now we are going to look at linear programming, which will deal with multiple limiting factors. Now, the maximum amount of products that linear programming can handle is only two. Okay. Now, what is the five-step approach to optimal plan? You might have seen up till now that in ABC also we did the five-step approach. In throughput accounting also we have done the five-step approach. Now in linear programming also we are doing the five-step approach. Why are we doing this? So that your life becomes easier. So that you know that okay, these are the steps that I need to follow. You just need to learn those steps. And with practice, you would not even have to rote learn it. You will automatically know it on your tips that okay, this is a linear programming question, this is the first five-step approach that I need to do in order to make the optimal plan. This is a throughput accounting question, this is how I need to go about it. Okay, so the five-step approach basically gives you a defined plan on how to go about your question. So the first thing is to define variables. Second is to establish constraints. Right now it won't make sense, but after this we are going to do an example question. Actually, two example questions, and I'll show you how it goes about. Third is the establish objective function. You need to make a formula, or you can say an equation kind of a thing in this. Graph the model. This you won't be doing. Why won't you be doing? Why won't you make the graph? Because now your paper is computer based, so the graph is not going to appear in that. Like, you wouldn't have to make the graph on the screen. Okay, previously when it was a paper based model, at that time students had to make the whole graph and then solve the question. But right now, since it's a computer based question, you wouldn't have to make the graph. And the fifth thing is to determine optimal plan. Now, what is the example? So the example says a company makes two products, P1 and P2. Material is in short supply, labor is in short supply, cash is in short supply. Requirement is how many units of P1 and P2 shall be produced. Coming back to our discussion, I did not mention that linear programming can only handle two limiting factors. I mentioned that linear programming can handle multiple limiting factors, but it can only handle two products. So there are only two products, but there are multiple limiting factors. Okay. Now we are going to perform the solution. Now, looking at the example, the first thing that we will be doing is to define variables. What do we mean by define variables? Let's give P1 and P2 a name, something that becomes easy for us to use. So we can say, okay, P1 is equals to X, P2 is equals to Y. Next, what we have to do is establish constraints. How will we establish constraints? These are basically equations, or you can say expressions. Equations are the ones with is equals to, expressions are the ones without the is equals to, right? So it says a company makes two products, P1 and P2. Material is in short supply, labor is in short supply, cash is in short supply. Now, I have not given in the complete details in this example, but moving on, I am telling you that okay, what if P1 is 4 kgs per unit. P2 is, let's say, 5 kgs per unit. And let's assume that only 400 kgs of material is available. Then what? So how will you make the constraint? Very simple. P1 was x, P2 was y. So 4x plus 5y. Now they're saying only 400 kgs of material is available, which means either your material should be equal to 400 kgs or it should be less than 400 kgs. You cannot use more than 400 kgs, right? Because basically material is the constraint over here. So less than is equals to 400. I hope this makes sense. Let's do some more examples. Let's assume P1 has only 3 hours per unit of labor and P2 has only around 5 hours per unit. Now what happens? Let's say that in total 650 hours were available. Let's make the constraint 3x plus 5y less than is equals to 650, because only 650 hours were available of labor. So you cannot use more than 650. You either have to use 650 or less than 650. Therefore, this becomes a constraint. Let's take another example into consideration. Two machine hours per unit for P1 and 1 machine hour per unit for P2. What is the total? Only around 100 machine hours available. Let's make the constraint 2x plus y. Why am I not writing 1y? Because when you write the variable alone, it automatically makes sure or it is automatically assumed that 1 is with that variable. So 2x plus 1y wouldn't make sense, which is why I am writing 2x plus y less than is equals to 100. Okay, so I am giving you some more examples that you should perform. Let's say total output must not exceed 50 units. Now what becomes your constraint over here? The demand or the output becomes your constraint. So how are you going to answer back? X plus y is less than equals to 50. Why x plus y? Because there are only two products. So whatever the amount of x you're producing and whatever the amount of y you're producing, adding them together should maximum make 50 units for you as your company. It should not make more than 50 units, which is why less than is equals to 50 units. Now let's say max 10 units of P1. The constraint does not apply to all of the units. It only applies to P1 over here. So what happens? X is less than is equals to 10. Similarly, max 15 units of P2. So y is less than is equals to 15. Next, now the situation is going to change a bit. At least 5 units of P1. I want you to take your time and see how you'll be doing this. In the meanwhile, I am writing some other examples and then I'll come back to the solutions. At least 8 units of P2. At least half of total output must be P1. Units of P2 shall be no more than 2/3 of total output. So around 4 examples for your practice. Coming back to the solutions, at least 5 units of P1. What does this mean? It is not saying maximum. It's saying at least, which means minimum. So what will you do now? X is greater than is equals to 5. I hope this makes sense. X is, sorry, not X in this case because it's at least 8 units of P2. So Y is greater than is equals to 8. Now at least half of total output must be P1. So they're saying half of total output. So you should know that, okay, after the is equals to, half of X plus Y will come. Okay, but before is equals to, you should know it will be greater than is equals to, and they're saying must be P1, which means X should either be is equals to half of X plus Y or it should be greater than half of X plus Y. Make sense? Now you can also simplify this further. How can you simplify this further? So this can, the 2 is going to go over here. Okay, I'm performing it here. So once 2 goes before the is equals to, it becomes 2x is greater than is equals to x plus y. Further on, what could happen? Simplifying it further, the x will go to the other side. It is adding over here. It will subtract before the is equals to. So 2x minus x is less than is equals to y. Simplifying it further, it becomes x is greater than is equals to y. I hope this makes sense. If not, please feel free to ask me. Now the last example says units of P2 shall be no more than 2/3 of total output. So let's do the easier bit first and let's focus on the key terms. What are the key terms? Units of P2 shall be no more than 2/3 of total output. So total output should be 2/3. Why am I writing this in bracket? Because 2/3 multiplies by x and multiplies by y. Okay, but it says shall be no more, which means it should be less than, the y should be less than. Now what happens? Y is less than is equals to 2x plus 2y over 3. So simplifying it further, the 3 goes to the other side. Over here it is dividing. On the other side it will multiply. I hope you all know the basic math rule. Again, over here the y is adding. On the other side it should go and subtract. So 3y minus 2y less than is equals to 2x. This becomes y is less than is equals to 2x. I hope this is understandable. I hope this is clear. Also, now we have seen multiple examples of just the second step, that is to establish constraints. Okay, so I believe the second step would be clear now. The first step is very easy, to just define the names, so I believe that should also be good to go. Moving on, we will now move towards the establish objective function step. How will we go about it? Establish objective function. So in this case, let's say P1 and P2 has been given. P1 uses around $40 contribution per unit. And P2 has around, let's say, $50 contribution per unit. Now, whenever they want you to make an objective function, they will also tell you the purpose of the company. The purpose means the company's objective basically. So it could either be profit maximization or it will be cost minimization. It could be either of the two. In this case, let's say the company's objective is to maximize profit. So in order to write your objective function, you will like to maximize company's profit. The objective function becomes 40x plus 50y. What does this mean? This means that whatever amount of units you're going to make of x, that will multiply by 40 to tell you the total contribution, plus whatever amount of units you make for P2, that is y, that will multiply by 50, and when added together this will give you the maximum contribution. When you get the maximum contribution, there's a chance of getting maximum profit as well, because after the contribution the only thing that you need to subtract is the fixed cost. So maximizing contribution means maximizing profits. I hope that this is clear. Let's say if the objective function changes, let's say it becomes P1 and P2 around $10 cost per unit for P1 and $15 cost per unit for P2. Now what happens? The company's objective is to minimize. So in this case, you will write the same statement but using different terms. To minimize company's cost, 10x plus 15y. This is the expression that you will give, and that is about it. Okay, so this is another example for establishing objective function. Next, we have the graph, the model step, which you won't be doing. So I'll keep it for when we are performing the questions. And after that, the last step comes that you will have to make the optimal plan. So that will also depend on the graph basically, which is why for now we are going to stop the example and we'll move towards the main question.